Hi, I'm Steve Matthews from Acoem Fiberline. Today we're going to demonstrate the horizontal shaft alignment app in the new RT-300. RT-300 is a new generation of reliability tool that incorporates multiple predictive diagnostic technologies into one platform. Today we'll focus on our horizontal shaft alignment app. So first thing is to address our setup here. This demonstrator is meant to represent a movable and a stationary machine, also generally considered the driver and the driven. So we have the sensors, two sensors called transmitter detectors, each one with a laser firing at the other side. So very quickly I can get set up with the easy to see line laser and clips. That is the entire setup process for mounting the sensors on the shaft. Now, I also want to make sure that my sensors are square to one another, which I've already done. Watch our other pre-alignment app demonstration where we talk about addressing our pre-alignment considerations with the RT-300. So we've already taken care of those pre-alignment conditions and we're ready to take a precision shaft alignment measurement. So the first thing we'll need to do is put in the dimensions of the machine. So from sensor to sensor is 8 inches. Then from the M sensor to the center of the coupling is 3.5. M sensor to the front feet of the movable machine is 0. And then front feet to rear feet is 7 inches. At this point, I'll select a tolerance. Shaft alignment tolerances are based on machine speed, so the faster the machine rotates, generally, the more precise we want the alignment to be. So as you can see, I've got all the dimensions input. I'm ready to take my measurements. A couple things that to note with the sensors here is we can start anywhere and stop anywhere on the shaft rotation. We'll take 3 readings. And these are digital sensors. All digital sensors allow us to apply some filtering for ambient light conditions. Now, the most important area where this is of concern is doing alignments in the sunlight outside. And so the digital sensor helps tremendously with that and makes it no longer an issue. So we're going to take these measurements. Again, starting anywhere and stopping anywhere. At 3 different positions. Next, what we're going to do is what we at Acoem Fiberline call a vertical alignment. This means that we're going to make one single adjustment where we do a shim adjustment and a horizontal adjustment with one set of loosen tightening sequence on the bolts. So as you can see here, we have a result in which I have some red, some orange, some green in terms of my shaft alignment tolerances. So the vertical, angle, offset, horizontal, angle, and offset. Now in the case of shaft alignment, we need all of these conditions to be within tolerance for the alignment to be good. Now we're going to go straight to the shim adjustment in which the device tells me exactly how much shim to put in or take out. In this case, we're adding shims. Now we'll loosen up the machine. Add our shims. And then be able to go straight into the horizontal alignment. Now you may have noticed that the machine bounced around quite a bit as I made those shim adjustments, and that's okay because with our true position sensing, it allows us to continually keep track of where one shaft is in relation to the other. As we can see, we're now out of tolerance in the horizontal as well. So using the arrows as guidance, it tells me which way to make my adjustment. So the numbers here at the feet indicate how much my adjustment needs to be. And on this side, in the front, I need to come over back towards me a little bit. And once I get close enough, my icons over here that indicate the shaft alignment tolerance will turn green. Once I have a shaft alignment intolerance, my alignment is complete. But before I finish, I do want to show you that the orientation of the picture can be adjusted based on which side of the machine the user's on. So this is a helpful way to make sure that you're tracking which direction to move the machine. So as you can see, it just flips the view back and forth based on whether you're on my side or on the camera side of the machine. Now, at this point, we'll take another measurement. Good shaft alignment practices are to take a second measurement to confirm the results of your alignment. And again, my measurement consists of 3 measurement locations at any position of the rotation of the shaft. So now you can see all my icons have turned green for the angle and the offset in the vertical and the horizontal. At this point, I want to document my alignment by creating a report. That creates a capture of the data that we've just measured and allows me to add this to other alignment reports, such as the pre-alignment reports, into one machine report. And once this data is saved to the device, it's a PDF and can be shared in multiple ways. We can either download it off the device directly, or we can email it directly, or we can send this report up to our cloud application, the Augmented Mechanic platform, which comes with the RT-300. So that's been a demonstration of our horizontal shaft alignment app inside the RT-300 platform. Thanks for watching. High quality and easy to use tools are not the only reason to do business with us here at Acoem Vibraline. We offer a unique lifetime warranty. Our repair and calibration lab, which is housed here in our Richmond, Virginia headquarters, is ISO 17025 qualified and offers 2 to 3 day repair and calibration turnaround times. We have built a world-class training organization focusing on a hands-on approach to all of our training programs. And our training team is all qualified as experienced maintenance personnel. We have produced hundreds of videos and blogs, largely focused on instructional content. You'll find many of the topics to be useful in shaft alignment and condition monitoring. And finally, we offer a complete package from our shaft alignment products to our new Acoem Advisor Reliability Services to our OneProd condition monitoring products. Thanks for watching. We look forward to earning your business now and in the future.